In this short video, we're going to demonstrate the profit maximization process when we're looking at a perfectly competitive market. Let's imagine that Socktopia, a firm in the perfectly competitive market for cotton socks, has a total cost curve of 38Q minus 6Q squared plus 1/3 Q cubed plus 150, where Q is pairs of socks. Our goal is to determine how many pairs of socks they should produce to maximize their profit if the market price is $18 per pair. What do we need to know in order to answer this question? We need to have a total cost curve or a marginal cost curve, and we also need to know the current market price. How do we go about solving a question like this? Well, the first step is if we have the total cost, we have to find the marginal cost by taking the first derivative of that total cost curve. Once we have marginal cost, we're going to set it equal to price and solve for Q. This is technically like a first order condition for a maximum, where we're looking at like the apex of the profit hill. Then sometimes setting marginal cost equal to price is going to generate more than one solution for Q. That's going to happen in our question. And when that's true, we need to check that the marginal cost is rising, and any Q that both sets marginal cost equal to price and generates an upward sloping marginal cost curve is going to be profit maximizing. So we sort of have a first order condition and a second order condition. So let's solve this question. Here's what we know. We have our total cost function, and we also know that price is equal to 18. We are trying to find the profit maximizing quantity of socks. The first thing we're going to do is we're going to find that marginal cost. As a reminder, marginal cost is just the derivative of total cost with respect to Q. So in this case, we have 38 minus 12Q plus, we bring down the 3 on the Q cubed term over here, and it cancels with the 1/3, so we're just left with Q squared. The 150 is constant, so it drops out when we differentiate. What do we do with this thing? We're going to set this marginal cost curve equal to 18, and we're going to solve for Q. I hope you recognize what's going to happen here. We have a Q squared term, so we're going to end up with a quadratic. So we get 38 minus 12Q plus Q squared is equal to 18. I recognize a quadratic has appeared, so I'm going to move everything over to the left-hand side of the equation, and at the same time I'm going to organize this in this sort of standard quadratic structure where the squared term is first, then the single Q value, and then the constant. So I end up with Q squared minus 12Q plus 38 minus 18, which is 20, equals 0. We have a quadratic. This one is actually quite easily factorable, so we'll factor it. Q at the beginning of both, and then I'm sort of looking at my numbers here, and I know I need two things that multiply to 20, and they also need to add to negative 12. The obvious solution is Q minus 2 and Q minus 10. Notice that minus 2 times minus 10 is 20, and when I do minus 2Q and I add minus 10Q, I get minus 12Q. So I sort of confirm mentally that I have successfully factored this. These are both equal to 0. So we can break this up into two. We have Q minus 2 equals 0, which implies that we have one potential solution where Q is equal to 2. And we also have Q minus 10 equals 0, which suggests we have a second potential solution where Q equals 10. So if we're thinking of this setting marginal cost equal to 18 as our first order condition, we've identified two stationary points. And we need to know which point where marginal cost equals 18 is the one that actually maximizes profit. And to do that, we have to look at the shape of the marginal cost curve. So our next step is to use the second order conditions to figure out if 2 or 10 is the maximum of profit, or the output that maximizes profit, I guess is a more correct way of doing that. And the second order condition, as we previously described, is that marginal cost needs to be rising. That means that we need to look at the derivative of our marginal cost curve with respect to Q and consider whether it's positive or negative and our two potential solutions. So we find the derivative of our marginal cost curve. It's negative 12 plus 2q. And then we're going to evaluate it at each possible solution. When q is equal to 2, this derivative of the marginal cost curve is equal to negative 12 plus 2 times 2. Negative 12 plus 4 is negative 8. Well, that's negative. That suggests that at 2 units, the marginal cost curve is falling. So let's see if the second order condition holds for our second potential solution. When q equals 10, the derivative of the marginal cost curve with respect to q equals negative 12 plus 2 times 10. Well, 20 minus 12 is 8. So this one's positive, which suggests that marginal cost is rising. And we can conclude that q equals 10 is our profit maximizing output. So notice this question is quite challenging, basically as challenging as it gets, because we identify two potential solutions when we set marginal cost equal to price, and then we have to use that second order condition that marginal cost is rising to confirm which one actually is our maximum output. So we've determined that our final solution, the profit maximizing quantity, is 10 units. And we're going to ask one last question. Should this firm, Stocktopia, shut down? And along with this question is this idea of, are they making any profit? So to answer this question, are they making profit? Should they shut down? The first thing we're going to do is we're going to form the profit function. Profit in its most general form depends on output, and it will equal total revenue minus total cost. So filling in what we know, total revenue is price times quantity. We have profit is equal to price times quantity minus our really long and hideous total cost function. So we have 38q minus 6q squared plus 1/3 q cubed plus 150. So that's our baseline profit function. It depends in this case on both price and quantity. Now that we've written down that profit function, we're going to evaluate it at q equals 10 and p equals 18, which is the profit maximizing solution that we found. So filling in what we know, we have that profit is equal to 18 times 10 minus 38 times 10 minus 6 times 10 squared plus 1/3 times 10 cubed, and I've run out of space, I'm going to carry down to the next line, plus 150. I knew that was going to happen. So we can start simplifying a little bit. We have profit is equal to 180 minus, I'm actually plugging all of this stuff in the parenthetical into a calculator because it's too big of a computation for me to do out by hand. And it turns out, because of this annoying 1/3, it turns out that this is equal to 263.33. So our profit when we produce 10 units and charge a price of $18 is actually negative, and it's negative $83.33. So remember, the question that we're trying to answer here is, are they making a profit? And should they shut down? So far we've determined no, they're not making a profit. They're actually making a loss of $83.33. But we can't determine whether they should shut down based off of this number alone. We need to compare this number to the profit they would get from shutting down. So our next step is to evaluate the profit function when q is equal to 0. So filling in what we know, we have profit when q is equal to 0 is price times 0 minus, not plus, minus 38 times 0 minus 6 times 0 squared plus 1/3 times 0 cubed plus 150. I managed to fit it this time. And let's see what happens. The first term is 0. The second term is 0. The third term is 0. The fourth term is 0. However, However, this term is not zero, and it has a negative sign because of the negative in front of the parenthetical. So we have that the profit when the firm produces zero is equal to negative 150. Now we have all the information we need to answer this question. Our firm is clearly making a loss. They're losing $83.33, but that does not mean they should shut down. In fact, they should not shut down because profit from shutting down is even larger. Shutting down would yield, negative. The losses from shutting down are even larger. So by shutting down, they would lose more money than they currently are by continuing to operate. If you want to think about it another way, you could say that by operating, they are covering all of their variable costs and a small amount of their fixed costs. And if they shut down, they would have to pay all of their fixed costs. So by continuing to operate, they're essentially minimizing their losses.